Okay, example 3. An object of mass 450 gram oscillates from a vertically light string once every 0.55 seconds. So the oscillation of the mass spring is started by being compressed. Okay, so it started by being compressed 10 centimeter from the equilibrium position, and then it is released. So write down the equation giving the object's displacement as a function of time. And then how long will the object takes to get to the equilibrium position for the first time, and then calculate both the maximum speed and acceleration of the object lah. Okay, alright, let's try and do this. So firstly, I'm gonna draw the situation. So this is the wall, that the ceiling that it is hanging onto. So the spring is basically being compressed. So so that is the mass, the block that is hanging on hanging by the vertical spring. Okay, lepas tu so we can assume that the equilibrium position is somewhere here, and then it is compressed up to 10 centimeter. Okay, so that compression gives us its amplitude lah, which is 10 centimeter. This one is negative 10 centimeter. Okay, so at this point here, the time is equal to 0 seconds. Okay, initially dia belum lagi kena release, so t equal to 0 lah. Okay, and then based on the question, we have been given the period, which is 0.55 seconds, and then the mass, which is 450 gram. Convert that into kilogram, is 0.45 kilogram. Okay, alright, so we know that the general displacement equation is equal to x a sine omega t, right? So from here we can then substitute all these values, since we have the value of a, which is 10, and then omega is basically just 2 pi over t, which gives us 11.4 radian per second. Okay, so dapat sudah the values, you can just substitute into here. So you get 10 sine 11.4 t. Okay, don't forget to write where x is in centimeter and t is in seconds. Okay, right, lepas tu, how long will the object takes to get to the equilibrium position for the first time? So we can then use this equation yang kita sudah kira tadi, yang we've determined just now, by letting t to be equal to by equating the value of x to be equal to 0. Sebab tayo cakap tadi, get back to the equilibrium position kan, so x equal to 0 lah. So 0, 10 sine 11.4 t, so 0 divided by 10 is 0, so you get shift sine 0 di sini. So 11.4 t, which will give you the time to be equal to, let me calculate, shift sine 0 divided by 11.4, which is equal to 0 seconds. Wait, that's not actually logical. I'm using radiant mode. Betul lah. Coba, let me check. Sine 0. Yeah, so the time